Welcome back to my online tutorial. In today's class, we have an Olympiad mathematics. It's actually a short problem involving exponents. Now let's look at the solution together. Now we have this humongous expression here, 2 raised to the power of the square root of 27 multiply 8 raised to the power to the square root of 75, all in bracket open and closed, divided by the square root of 48, everything to the power of root 3 on 5. If you look at this expression carefully, what we have to do is to take care of the radicals. Meanwhile, let us write it out for those who are trying to ace their scores or become better in mathematics. So the square root of 27 is actually the square root of 3 multiplied by 9. If you are simplifying radicals to their lowest term, it's advisable you use two factors of which one is a square number or a perfect square. It's the best way to go. Otherwise, one can multiply 27 to 27, but it does not in any way simplify the surd. So if I take the square root of 3 and take the square root of 9, this is going to give me 3 root 3. Or the square root of 3 is 9. Similarly, I also investigate the radical 75. So the square root of 75 is actually equal to the square root of 3 times 25. Why the choice of 25 and 3? Because 25 is a square number and 25 multiplied by 3 is actually 75. So this will be the square root of 3 multiplied the square root of 25. That should give us, 5 root 3. The last but not least, the radical 48 can be broken down into the square root of 3 and 16. 3 multiplied 16 is 48, and 16 is a square number. So this is going to be the square root of 3 multiplied the square root of 16, and that will give us 4 multiplied root 3, which is root 3. So in the original problem, in place of the radical 27, we shall write 5 root 3, 3 root 3. In place of root 75, we shall write 5 root 3. In place of 48 or square root of 48, we shall write 4 root 3. So I can actually take this off so that we can simplify based on what we have. Now, I am doing this for those who are coming up in mathematics. Otherwise, for someone who's already strong, you can bring this out, you know what the component sort will be in the lowest form. So it's going to be 2 raised to the power of 3 root 3 multiply 8 raised to the power of 5 root 3, all divided by 4 raised to the power of 4 root 3. Everything in brackets raised to the power of root 3 on 5. Now we have done very well. So we can see that the radicals have been simplified in their lowest forms, but we have a base number here, 2, 8, and 4. And we know very well that 8 is 2 multiplied 2 in 3 places, which will give us 2 to the third power, or 2 cubed, or 2 raised to power 3. 4 is 2 squared, which is 2 times 2. So I can write it to become 2 raised to the power of 3 root 3 multiply 2 raised to the power of 3 all raised to the power of 5 root 3 divided by 2 raised to the power of 2 all raised to the power of 4 root 3. Everything all raised to the power of root 3 on 5. This is a beautiful question, hence it's an Olympiad problem. Now, here we are going to apply the power rule. When the power is raised to another power, we have done several videos involving indices, you can check them out. When the power is raised to another power, we multiply the powers. So we are going to write 2 to the power of 3 root 3 multiply 3 times 5 is 15. 2 to the power of 15 root 3 divided by here 2 multiply 4 root 3 is 8 root 3. That would be 2 raised to the power 8 root 3. Everything in parentheses, all raised to the power of root 3 on 5. Now at this level, we are going to use the multiplication law of indices. Because that multiplication law says that if you have two or more numbers or letters raised to different exponents, you should add the exponents together. So that law is what we have to apply here. Now, the bases are the same here. We are going to add the powers. This is going to give us 2 raised to the power of 3 root 3 plus 15 root 3, all divided by 2 raised to the power of 8 root 3, everything raised to the power of root 3 on 5. Now, as you can see, we are home and dry. Now, if I add 3 root 3, these are like terms, 3 root 3 plus 15 root 3. So I say 3x plus 15x. That will give us 18x. So I can write this to be 2 raised to the power 18 root 3 divided by 2 raised to the power 8 root 3, all raised to the power of the square root of 3 on 5. Now, we have two base numbers here raised to different exponents. And the division rule or quotient rule of indices says that if you have this, if you have two base numbers, it could be letters, raised to different exponents, you subtract the exponents. So if you use that law here, you are going to be having 2 raised to the power of 18 root 3 minus 8 root 3, all raised to the power of square root of 3 on 5. So at the end of the day, we are done with this Olympiad problem. So 8 root 3 minus 18 root 3, sorry, minus 8 root 3. This is like 18x minus 8x. I'll give you 10x. So we have 2 to the power of 10 root 3, all raised to the power of square root of 3 on 5. Now, here, as if you can see carefully, this is power raised to another power. So we make do with the same power rule. So we have to multiply the two powers. So the final step is 2 to the power of 10 root 3 multiply root 3 on 5. As you can see very well, 5 can cancel out 5 and can divide 10 to give 2. So we are going to be having 2 multiply root 3 multiply root 3. And root 3 multiply root 3 is going to give a 3. If a surd multiplies a surd, we are used to that, the surd will disappear. So we will have 2 to the power of 2 times 3, which is 6. And 2 raised to the power of 6 is 2 multiply 2 in 6 places. If I take 3 and take 3, that will give me 8 times 8, which is equal to 64. So this is the answer to this Olympiad problem. As you can see, it's a nice question. Thanks for watching. Continue to like, share, and comment on our video. See you next time. Bye.